In our previous videos, we have been integrating with respect to the x-axis, but for this video, we will be integrating with respect to the y-axis. So our previous videos would look something like this. And we have the equation y is equal to the function of x, and the area will be the integral of the function of x dx evaluated from a to b. Now, if we have this example and we want to get the area of the shaded portion, we can still integrate with respect to the x-axis. So first we need to get the area of this rectangle like this, and then we get the area of the bottom part, and then we subtract the area of this one from the rectangle, so we will be having this shape. But still there's another smaller area here that should be subtracted. So we get the area of the small rectangle, we get the area of this small curved area at the bottom, and then once we subtract this one from the rectangle, the answer we will have to subtract from this area, which is very, very complicated. There's another method though. We can imagine that this is quite similar to our previous videos, but it is rotated 90 degrees counterclockwise. So instead of integrating with respect to the x-axis, we integrate with respect to the y-axis, and it will be easier, evaluated from 1 to 4. So for this case, what we need is the value of x as a function of y. So it's similar to this one but reciprocal. So this is our equation, y is equal to the square root of x, but we want to have the value of x as a function of y, so let's swap this around. So square root of x is equal to y. Now we want to have it as x, but there's a square root, so we just square both sides. We have x is equal to y squared. So this is our equation now to evaluate it with respect to the y-axis. So the area would be the integral of the function of y dy. So it's dy this time. In here is a function of x dx. In here is a function of y dy. Evaluated from 1 to 4. From 1 to 4. So substituting our value of x, or the function of y, it will become y squared dy. So we will be integrating that. This will become y cubed over 3 evaluated from 1 to 4. So the area would be 4 cubed over 3 minus, so we substitute 4 in here, and then we substitute 1 in here again, so 1 cubed over 3. So that would be 64 over 3 minus 1/3. That would be 63 over 3. So that will be our area. 63 over 3 square units. Example number 2. we would want to get the area, shaded area of the equation. Y is equal to plus and minus square root of 1 minus x, which is this one, and the curve, the equation y is equal to plus and minus square root of x plus 1, which is this curve. So if you will remember, this example is similar to my previous example, like this. And to get the area of this one, we need to get the integral of the top minus the bottom. So this would be the top and this would be the bottom. And if you compare it to this, our example, it is, if you can rotate this one 90 degrees counterclockwise, this will be similar to this one, and this will be your top, and then this will be your bottom. So equation, this equation minus this equation to get the area. But first we need to manipulate this equation. We need to get the value of x. To integrate with respect to the y-axis, it had to be x equals to the function of y. So we have to I'll just copy this one first. Y is equal to plus and minus square root of 1 minus x. Squaring both sides, we will get y squared is equal to 1 minus x. I'll just do a shortcut to get the value of x. This one goes here. X is equal to negative y squared minus 1. So this is your equation on the left. The equation on the right would be, so y is equal to plus and minus square root of x plus 1. Squaring both sides, we have y is equal to x plus 1, y squared. So manipulating this equation, you will have x is equal to y squared minus 1. So this is your second equation. Now we have to get the point of intersection. So as in my previous videos, we get the value of x in here equal to the value of x in here. So that would be negative y squared minus 1 is equal to y squared minus 1. Sorry, this is plus 1, this is plus 1. Yeah, x, yeah. So to combine, we will have 2 is equal to 2y squared. We can divide 2 on both sides, so 1 is equal to y squared, or y squared is equal to 1. Getting the square root of both sides, y would be equal to plus and minus 1. So you have two values of y. Y is equal to 1 and y is equal to negative 1. So these are the points of intersection. So this would be your negative 1 and this will be your 1, positive 1. So you will evaluate it from negative 1 to 1. So we can now solve for the area. Area is equal to the integral evaluated from negative 1 to 1 of this equation, negative y squared plus 1, negative y squared plus 1, minus this equation, the bottom one, y squared minus 1, y squared minus 1, and that would be dy. I'm so used to dx. Now we can combine with this. We'll just distribute this one first. make it easy. So this will be negative y squared plus 1 minus y squared plus 1 dy. So this would be area is equal to integral of negative 1, 1. So we can combine negative y squared and negative y squared. That would be negative 2y squared. So negative, see, this is plus 1, this is plus 1. So plus 1 and plus 1, it will be 2 dy. So we can take out the 2, we can make it negative 2 from the equation, and this will become 2, negative 2, if we take out negative 2, and then the integral of negative 1 plus 1, we can take out the constants because it doesn't affect the value of the variable. So what would be left will be y squared minus 1 dy. So this one became negative 1 because negative 2 times negative 1 is positive 2. So what we have, we can now integrate. So this would be negative 2 still. If we integrate this one, it will become y cubed over 3 minus y, evaluated from negative 1 to 1. So the area would be, so we substitute 1 to both values, to both y's. So negative 2, so that would be 1 cube over 3 minus 1. So this will be this one, substituted with 1 will be this one, minus, so we substitute negative 1 in this and this one, so that would be negative 1 cube over 3 minus negative 1. So there's still negative 2 in here. 1 cube is still 1 over 3 minus 1 minus negative 1 cube would still be negative 1 over 3. So this will be plus 1. So this is like over 1 over 1. Make it easier to compute. This will be 1, let's say the LCD is 3. 3 divided by 3 is 1 times 1 is 1. 3 divided by 1 is 3 times 1 is negative 3. Minus, there's still a bracket here. So LCD of this one is still 3. 3 divided by 3 is 1 times negative 1 is negative 1. 3 divided by, let's see, 3 divided by 1 is 3 times 1 is positive 3. And this would be negative 2. 1 minus 3 is negative 2 over 3 minus negative 1 plus 3 is 2/3. So this would be negative 2. So there will be negative 2. Negative 2 minus 2/3 will be negative 2 over 3 plus negative 2 over 3. It will become negative 4 over 3. So the area would be 8 over 3. So computing for the area is similar to like following the recipe in a cookbook. The hard part would probably be the computation using your basic skills in math. So some teachers allow calculators, but some teachers do not allow. So you need to be good at the basics. Even I make mistakes sometimes on the science. So once you understand the basic principle, it will be easy to compute for the area. And if you're not still adept to computing basic math skills, you have to brush up on your fractions and your exponents. So if this video is able to help you, please like and subscribe.